Hi everyone, and if you're new here, welcome back to Taker Maths. This channel will be focusing on additional mathematics and modern mathematics of Form 4 and Form 5. And we have just finished the Form 4 additional mathematics chapter 2, and we will be heading towards chapter 3 soon next week. And today we are going to actually discuss some past year questions, especially on the two chapters that we have already did. So, yeah, let's have a look at past year percubaan questions, trial exam questions from Selangor Set 2 2019. So, I have taken like two questions from we are going to discuss about regarding the chapter 1 functions. So yeah, let's have a look. So this question is, it says that there's a mapping happening. This is one of the arrow diagram that we have seen in the previous videos. Yeah, this is one of it, and this arrow diagram has three names over here and three classes. And Lima Mutiara, and the mapping goes like this and like this and also like this. So the question is range of the relation, and also is this a function. So they have given arrow diagram for us to check if to find out the range of relation, and also to find if this is a function. So this is one of the a trial exam question, and if you can see, it's quite pretty easy compared to those we have studied in chapter 1 additional mathematics form 4. And so let's answer this question now. So it says the range of relation. So as we have already discussed earlier, range is the codomain, and range supposed to be taken from codomain, and range is the one which is involved in the mapping. So range is which is involved in the mapping. So if you can see here, the involved in the mapping is just the 5 Berlian and 5 Mutiara. So you just write down 5 Berlian, 5 Mutiara. And that's all. As simple as that. And also we have a question asking if this is a function or not. Adakah ini satu fungsi? And if you can see, for it to be a function, we have to make sure it passes the DOSI test. I have already thought about this, and if you haven't checked out my videos, please do. DOSI means this part where the left hand side is going to be domain or image, and the right hand side is going to be codomain, also known as, this one is going to be object or image here. Okay, so it's do c. So this side is domain or object, and this side is codomain or image. So if you test through this, if you have a domain and a codomain, or also known as object or image, then this is automatically yes, this is a function. Okay, so yeah, it's quite simple, and just have a look that this is actually a trial percubaan question, and you don't really have to think too much about it. It's very straightforward, it's very simple, and it just needs some practice. Okay, so let's have a look at another function question from the same year, trial paper, which is going to be, they are asking the map. The question is, what is g negative 1, and for b, the object of 3. So let's solve for a first, and we so now if we write this thing in equation form, we will definitely get, this is going to be gx equals to modulus 4x minus 5. Okay, what does this modulus mean? Modulus means so this this two straight lines is called modulus. And what does modulus mean? If there's a number or unknown inside the modulus, the number or unknown is going to be always positive. So whatever is inside the modulus, it's going to be always positive. Okay, so the value will always be positive. Even if you, let's say, if you have a negative x modulus, this is equals to x modulus. So automatically the modulus thing will cancel off the negative value, and whatever you put inside these two straight lines, it's going to give you a positive output, or a positive image, or a positive um, answer. Okay, and now let's answer the question. So we have that gx is equals to modulus 4x minus 5, and our first question is, what is g bracket negative 1? So if you can see, which means we are substituting, we are going to equate x equals to 1 negative 1. So they are asking, what is the answer if we substitute x with negative 1? So always write this as, substitute all x's with the negative 1, and then solve it. 4 times negative 1 minus 5, you can always use your calculator, or you can calculate step by step. 4 times negative 1 is going to be negative 4 minus 5, and this is going to be negative 9, which is going to be simply 9, because modulus any negative number or positive number is always going to be positive. Okay, now they're asking, what is the object of 3? So as we already said, object of 3. So we saw the DOSI formula just now, and they are asking the object part here, which means this is called the image here. Okay, and image, as this is in this side, this means this is the answer. So we know that gx is equals to 3, or modulus for x minus 5 is equated to 3. Okay, and why is that? Because they are asking about the object of 3, which means 3 should be the image, and image means the answer. Answer means gx is equals to 3, and gx is actually modulus for x minus 5. Okay, you can always calculate. Okay, now as we already know that modulus gives always a positive answer, so this 3 is actually positive. And then okay, but now we have to remember that for example, this this modulus makes any positive or negative number become positive. So this 3 can be equals to positive negative 3, right? Maybe this inside this solution, this function inside might be a negative number because of the modulus it became positive, or it can also mean that a positive number has been modulated to a positive number. So the possibility of the 3 can be 2 possibilities. Now we are going to solve for it. So let's say we are going to have two types of answers here. So the first one is going to be 4x minus 5 equals to positive 3, and 4x minus 5 equals to negative 3. And then solve for it. You will get 8 here, and this is going to be simply 2, or you can always solve this one also using calculator. It's going to be 2, and x is going to be half. So x can be 2 or x can be 1 over 2. Mainly because of the modulus part, we can always get a positive or negative input. Okay. Hopefully you guys understand what I'm trying to say, because this is kind of confusing. Let me explain again. So what I'm trying to say is modulus is let's imagine modulus as a machine, and whatever you put, let's say negative or positive value inside that modulus machine, it's going to give you a positive number. So which means this thing here can be positive or negative, but somehow it's going to give only positive 3. But now as we are solving for x, we have to see two possibilities where it can be either a positive output or a negative output, because we don't know what x is. So to find out that, we should always look at the two possibilities. Exactly the same concept as I have mentioned in earlier videos for the um, squares, like 2 square is equals to 4 and negative 2 squared is also equals to 4. So when you do the square root 4, you will always get positive negative 2, because both this will give the same value, exactly the same concept. This 4x minus 5 equals to 3 can give you a positive 3 or negative 3. Okay. Yeah, hopefully you guys understood this concept, and if you don't, please let me down in the comment section. And we just discussed some of the function or the chapter 1 questions that came out in the trial paper or Parchuban paper. I will see you guys in the next video, and if you didn't subscribe yet, please consider subscribing the channel to learn mathematics for free. Thank you.